Morning. This is Professor Ramanandan RHS, Department of Mechanical Engineering, Maharaja Institute of Technology, Mysore. Today's session, we will start our discussion on subject fluid power engineering. Subject code is 18ME55 and faculty. So myself, Ramanandan RHS, my colleagues, Professor Krishna Prasad and Professor Sachin B. They have already engaged few sessions to you based on fluid power engineering. In today's session, the contents or the topics which will be delivered are, so you can see on the right hand side of the board. So we will start our discussion on seals, seals and hydraulic conductors and fittings. Under seals, we will discuss what is the significance or need of a seal, followed by what are the functions. So what does it do? Basically function. And next we will see how they are classified. If there is something called as a seal, how many types are there? So what are the different issues which will make us to use seals and design various types of seals for a particular application. Then comes the material aspect when we go to design. So seal, if I know a particular issue, I know how it is to be solved, then with what seal has to be made of. So that is our discussion with respect to sealing materials. Followed by hydraulic conductors and fittings, the next successive topic. So conductors and fittings are nothing but basically pipes. So obviously how in a human body we have conductor which is required for a fluid flow. If it is a human body, we have various types of fluid. Say take an example of blood. For the blood you need blood vessels, arteries or veins, various type of nervous system which are arranged to supply blood to various parts and components of a system. So similarly in a hydraulic system, I am dealing with fluids, air and liquid as a fluid. So I am doing work with the help of a fluid there. We already discussed fluid power is getting transmitted into mechanical energy. So I need to transmit energy, force and power with the help of fluid. So how do we do that? It is with the help of, because fluid has no shape, it takes the shape of a container. So therefore it needs some arrangement or a solid component through which it can be propelled under certain operating pressure, so that you can convert fluid power into mechanical energy. So basically a hydraulic system can work efficiently, precisely, smoothly with the help of hydraulic conductors and fittings. So how you use your engineering technical knowledge to design a pipe, that plays a vital role now. So that in that topic we will discuss various types and details of what are the types of fittings or pipes, simply to say various types of pipes and why these various types of pipes are required and what are their particular functions. So both of the topics are nearer to each other, based on a fluid flow. So we will enter into first topic of the day. It is nothing but seals. So before entering into any topic, I already told you, go word by word. So it is seal. Why it is needed? If there is a component in a particular system, our understanding should be in such a way that why a seal is required. I have written here, just observe, common problem is leakage. So in any fluid flow, since it takes the shape of a container, it has no fixed shape. Major issue what we face in dealing with fluids is the leakage problem. Since you cannot design a single piece component of hydraulic system, it is a various, I have already told you, a system is nothing but it is a group of elements. There will be pipes, there will be valves, there will be actuators like pumps, motors, everywhere. So fluid will be directly or indirectly in contact with all these components. So you have so many components through which a fluid has to flow. So obviously fluid is one such substance where you cannot design Okay, actually a complete leak proof system, that is what we are speaking here. So one cannot, okay, we have to design a leak free system, but you cannot design a 100% leak proof system. Okay, leakage can be of two aspects. I failed to tell you before. So leakage can be, okay, internal or external. I already told you a liquid is nothing but it has ability to flow. Its motion obviously will cause the solid to get damaged, or a solid will keep on wearing and tearing because of the shocks or vibrations or any of the reasons, improper installation. Okay, if we come to internal leakage, okay, so what makes leakage to be internal? So major reasons, few to quote, are maybe for lubrication purpose we leave some clearance. Okay, we people are mechanical engineers, we will understand very easily why do we leave a clearance there in any component, a solid component. Because for the lubrication purpose we leave some amount of clearance that will cause internal leakage. Okay, internal leakage is not that threatful because internal leakage can be encountered. So you can divert the fluid to the tank, okay, with the help of a return line. Okay, but why do we have to encounter internal leakages? It affects majorly the power efficiency. Okay, it affects the power. The end aspect of any fluid power system is we have to convert fluid energy into mechanical energy. That is affected because of the internal leakage. The whatever operating pressure fluid has to travel through the path, it will get diverted to the tank. So obviously there is energy diversion to the tank. So sufficient energy cannot be converted into mechanical energy. So power reduction takes place. Your fluid power system will not be that efficient. Is that clear? So internal leakage is because of lubrication purpose we have left some clearance. That is a major reason. Okay. External leakage. Okay, this is very hazardous in nature because fluids are mineral oils, petroleum oils, synthetic fluids. Few are suffocating. They are, okay, they are fire hazardous in nature. They can be suffocating, very problematic to breathe. Okay, if leakage takes place externally, it can be hazardous or dangerous to the user or who is the one who is nearby, okay, interacting with any fluid power system. So reasons for external leakage. Okay, so reasons for external leakage, may few to quote, may be improper installation. Okay, during installing a fluid power component, okay, we might fail to incorporate the installation standard procedures. Okay, the next other reasons may be the failure in, okay, drain lines. Okay, wherever the fluid should get drained appropriately, if it is not getting drained appropriately, that also leads to leakage. So it may be, okay, the contamination within the fluid, that also can cause external leakage. If the fluid is contaminated with some mineral particle or dust particle, okay, that also leads to external leakage. So all these things are related to leakage. So in order to encounter this leakage, okay, you need a component called as seals in any fluid power system. So before understanding anything, you should know why it is existing, okay, and how it is existing and to what it is used. Okay, so now we are in a stage where what makes us to design a seal to a particular system. So now we have a brief idea. So it is major problem is leakage. It may be internal or external in fluid power system. Okay, so how that can be encountered? Because it is very difficult, I told you, very difficult to design a complete leak proof system. Okay, so we can make it leak free rather than making it leak proof. Okay, leak free is nothing but that itself, okay, will not reveal everything to you. So you have to understand it this way. Okay, how to make system leak free? Okay, you cannot make it leak proof. So you can do few things like proper maintenance. Okay, this is one of the solution for making a leak free system. You have to maintain constantly any hydraulic system by few measures. I will tell you what you can do. Okay, proper maintenance and selection of fluid. So what fluid should be used for a particular fluid power system, that should be taken care of at the design stage itself. Okay, this is a solution for this problem. Okay, so proper maintenance. Okay, I already told you, you should maintain it by continuous monitoring. Second thing is select appropriate fluid, okay, which is compatible to your fluid power system with respect to temperature, pressure, okay, operating conditions, working style, everything. Okay. So that makes us, okay, to study seals. So that will be the solution. Okay, to encounter leakage, we have designed a material called as seals, which is used at various components or systems in a fluid power system. So next topic comes is, okay, what is the function of a seal? So now you know a seal is nothing but it is a material which is used to avoid leakage. So functions of a seal is, okay, first function is prevent leakage. So to prevent leakage, it is a major reason why we are using seals. Second reason is prevent dust from entering into the fluid power system. I already told you. So you have to take care of leakage. Second thing is contamination of the fluid flow should be avoided. So that itself will help you in designing efficient system. So seals will prevent you, okay, from the external dust particle entering into the fluid line. Third important function is maintain pressure. Okay, so in case of any hydraulic conductor, if you don't maintain enough amount of pressure, say if the fluid gets internally leaked to the tank, I already told you. So internally leaked to the tank, it will affect the efficiency of a system. You have to maintain certain pressure in the pressure line of the fluid flow. So that makes you to use seals, because if you use seals, it will avoid leakage. So you can maintain a particular optimum pressure in any fluid flow or flow line in a fluid power system. So third important function is to maintain pressure. And fourth important function, okay, major function is enhance service life and reliability. So service life, if you are opting anything in our day-to-day life, we will always speak about guarantee and warranty. So company will claim a, okay, guarantee. Okay, I will assure that this particular component will function till this period of time. Okay, and he will be testing that component for a certain period of time, and he will give a warranty period. Okay, this component will function efficiently if you use it at a standard condition like this. It functions for, okay, a definite period of time. So that is warranty. We already know this. That is called a service life. If you take a mobile phone, okay, it may last for 3 years at a, okay, present time frame, because technology keeps on updating. So a mobile phone lasts for around, okay, 3 years. If you take food components, like example is pickle, they will mention it 12 months before the manufacturing date. It is the service, okay, it is the quality of the pickle or a food product. So like that, you can give n number of examples for service life. So any mineral oil, or it may be any component, machine tool, it will have a service life. So I have to enhance the service life. Okay, that is the main purpose of using seals. Otherwise, you should keep on replacing the hydraulic component. Okay, by using seal, you are enhancing, you are improving the life of hydraulic component. And next is reliability. So seals are reliable because fluid has a different properties like, okay, whenever the things are in contact with the fluid, it swells. Okay, it will get swollen, or it may get damaged, wear and tear occurs. Okay, if seal is one particular material which will help, okay, to avoid absorption, to avoid, okay, wear and tear of the material, to avoid leakage. So all these factors, it is relatively cheap in, okay, using a seal material or a sealing in a hydraulic conductor, so that it makes us reliable by learning all these aspects of seals. These are the 4 major functions of seals. Next we will go to topic classification. I already told you, if you are studying anything, so you should study why it should be used and how that should be used and what makes us to study that and what are the types. So that is how the flow should be. So if there is something called as a seal with all these particular function, what are the various forms of seals? Why do you need different types of seals? Or if there are types of seals, what are they? You should know. Okay. So on the basis of few things it can be classified. Classification is always on the basis. Say if you have cereals or grains, we classify cereals or grains into different aspects. If there are food items, generally if I say food, we will classify them into solid food, liquid food, like that. Okay, if in case of a solid food, we classify them into cereals, grains, pulses, vegetables, fruits. Okay, on basis of, we classify them on particular basis. We classify cereals as a cereal based on its nutritional contents, based on its external appearance, based on few attributes. We classify some food item as vegetables because they are plant generated, they have a particular type of attributes. That is why we classify them as vegetables. So like that, classification is always based on something. Okay. So here in case of seals, the classification are based on 4 bases. First basis is method of sealing. Okay. Second one is relative motion. Third basis is geometric shape. Fourth one is sealing materials. Go word by word now. So that should be the appropriate approach to any subject, because we are readers, we are listeners. Okay. So a reader or a listener should always go word by word. Keep hearing, keep looking. That is how one can understand a subject. Okay. So method of sealing. Say, what are the types of methods then? We classify them into 2 types. Positive seals and negative type of seals, okay, based on method of sealing. Okay, second type is based on relative motion. Okay, relative motion, that means to say, you can understand it this way. If there is motion, there are 2 components. One is moving or one is fixed, or both are fixed, or both are in motion, or both are in rest. These are the 4 cases that can exist in relative motion. Okay, both should be at rest, or one should be in motion, one should be at rest, or both should be in motion. Okay, these are the few cases. Relative motion, that means to say one is moving with respect to other. Okay, based on this we classify them into static seals and dynamic seals. So in case of static seals, one component is in a state of rest, and other component is moving, or both of the components may be static. That should be the case. Usually both the components are rigidly in connection with each other. That is how we classify static seals. If both are in rest, they are connected to each other, that makes you a static seal. Okay, a seal which is connected to that component which is not moving is called a static seal. Dynamic seal is nothing but where a conductor or a fitting is moving with respect to another, and seal is also keeps on holding this component which is moving with respect to each other. Okay, with respect to each other. That type of seal is called as dynamic type of sealing. Based on geometric shape. Okay, based on geometric shape, that means to say visual appearance, how it looks, that makes us to classify them into 2 to 3 types. See, we classify them into based on their shape, like O-ring. Okay, in your at homes you can see for the pipes. Okay, we fix something called as O-ring. That is a seal between 2 pipes. Okay, O-ring seal, or we say unions, pipe unions or collars. That is what we say. Plumbing work, if you have anywhere dealt with all those things, we will use something called as a collar to connect the junction of 2 pipes. So that seal, if it is in the shape of O, we classify it as O-ring. Okay, if it is in the shape of T, we classify that as T-ring seal. Okay, usually T-ring will be supported with backup rings because it is T in shape, where whenever a linear component will come, we have to give them a supporting material called as backup rings, T-ring seals, and you have V-ring, you have U-ring. Based on their geometry shapes, we classify them into various types of seals, okay, that are usually used in case of seal. Okay, last one is based on material, we classify them into different types. So based on material, it is usually I will mention some 4 types of materials. Neoprene is one such material, okay, nitrile or buna-N, that is what we say, chemical names of material. And then you have, okay, Teflon, and finally you have fluoroplastics and fluoroelastomers. Okay. So in sealing materials, there are 4 types, I already told you. Neoprene is one such material which works at a temperature of say below 65 degrees centigrade. So it is availability is cheaper and it is compatible with few fluids because the operating temperature is less than 65 degrees centigrade. You know that whenever fluid is flowing, mineral oil, hydraulic fluids, non-edible oil will have different viscosity, and the viscosity is directly related to temperature, because if you provide a heat, viscosity keeps on changing, and if you make a viscous fluid flow rapidly at a higher pressure, it will yield heat. So that makes us to think about, okay, what is the temperature for a particular operating pressure, how should I maintain that temperature. If that temperature is not completely dealt with a sealing material, okay, that will lead to leakage of the fluid. So neoprene has a working temperature of well below 65 degrees centigrade. If the system temperature is, okay, pipe temperature is less than 65, you can use neoprene undoubtedly. Second material is nitrile. If the fluid working temperature is around, okay, minus 65 to 150 degrees centigrade, so that temperature of fluid, you can use a material called as nitrile or buna-N. Okay, third type of material is, so these are all can be chosen based on temperature range. So finally you have Teflon, so whose wider temperature range is more than 250 degrees centigrade. So minus 50 to 250 degrees centigrade is the temperature range of Teflon. Last one is fluoroplastics. So where fluorine is added to plastics or fluorine is added to elastomers like synthetic rubbers. That is why they are called as fluoroplastics and fluoroelastomers. Okay, so the usage is too high because it can work at a temperature of 300 degrees centigrade. So I am telling you in an ascending order. Okay, neoprene is 65, nitrile is minus 50 to around 150. Next comes your Teflon, minus 50 to 250. Finally, okay, your material fluoroplastics or fluoroelastomers, which works at a temperature range of more than 300 degrees centigrade. If the fluid temperature range, its viscosity is undisturbed, okay, at a operating pressure till 300 degree, compatibility can be achieved by using fluoroelastomer sealing materials that can sustain that amount of temperature from the operating condition. Okay, based on temperature, we have to design by selecting proper type of sealing materials. Okay, this is about seals and sealing materials. So our second topic of discussion is hydraulic conductors and fittings. So you can see here, already told you, so for a fluid to flow, you have to provide a medium, okay, basically pipes. So it can be of 4 types: steel pipes, steel tubings, plastic tubings, finally flexible hoses. There are 4 types. Why there are 4 types? You should think always. Okay, while discussing things, I mentioned application makes us to think what are the types required, because for every application we cannot design only a single system. Okay, there are fluids, they have different viscosity, they have different temperature, they have different pressure. You have to focus on energy, efficiency, all these factors cannot be achieved in only one type of a system. Okay, for conductor, okay, if you want a lengthy conductor, say length should plays a vital role, we prefer something called as steel pipes. Okay, if you want a shorter length, we go for steel tubing. Okay, if I want flexible type of pipe, it should be bent, it should be easily available, it should be compatible, okay, it should be reliable, its availability should be too high. I go for plastic tubing. So depending on my purpose and depending on application. If I want to design a very robust system of shorter length, I go for flexible type of hosing. So this you might have seen at your homes. Gas pipes, we use it for stove. From the LPG cylinder to stove, for a shorter connection, we use hose pipes usually for air. Okay, less than 100 psi pressure. For a low pressure systems, we use hose pipes usually for pneumatic system. Okay, we'll just brief out why these steel pipes are required one by one. So steel pipes major criteria is we should focus on size of the pipe and thread designs. So usually pipes are, it may be usually threaded because we have to connect one pipe to another pipe. So how do you specify a size and what do you mean by a thread? If you have these two knowledge, you can understand any pipe. I have already told you pipe is classified on its length. If the length is too larger, we call it as a pipe. Okay. So I mentioned in the drawing here, these are called as 40, 80 and 160 are schedule numbers. Okay. Schedule numbers, as they keep on increasing, okay, pipe wall thickness keeps on increasing. This is wall thickness, you can see here. Schedule number is 40, wall thickness is quite small. Schedule number is 80, wall thickness is relatively larger than this. Schedule number is 160, wall thickness is larger than these two. So as the schedule number, say 40, 80, 160, that keeps on increasing, wall thickness also increases. So this is based on pipe classification. So threading is required for mating of female and male parts. Since I am connecting one component to another, because I cannot design a very lengthy pipe that will cause shock and vibration problems, I have to connect one pipe to another pipe. How do you do that connection? With the help of sealing material and internal thread. So one should be having internal thread and the other should be having external thread. That makes us to reach junction point so that fluid will flow precisely from one pipe to another pipe. So threading is required. Okay, second type is already told you steel tubing for smaller length of pipes, and you can avoid seals here because we usually mention it as tube light, valve tubes. We are already using these terminologies. Tube is nothing but a smaller component compared to pipe. If it is lengthier, we call it as pipe. If it is relatively smaller, we call it as tube. Section is circular only. Okay, section is circular because rolling friction is too less. That is why we use circular or tubular pipes. Okay, so tube is usually smaller in length. Seals can be avoided and it is cheap and useful. Okay, plastic tubing, I already told you, it can be easily bent. It is cheap for low pressure pneumatic system. It is available, susceptible, and it is compatible with more number of fluids. So materials may be polyethylene, polyvinyl chloride, CPVC, and polypropylene. All these are plastic materials which are having these properties from which plastic tubes can be generated. Last one is flexible hoses. You can see here it is made up of various cross section from external to internal. That is what is displayed here. So this is the most external part where outer layer is of synthetic rubber. Next successive layer, second layer is made up of wire braids. It will be made up of copper wire or steel wires. Okay, so that wire braiding is to provide reinforcement or strength to the external pipe, as well as internal pipe. So pipe will be successive layers. There will be 3 to 4 layers of pipes in a single pipe. Okay, third layer will be for higher pressure. Additional braid are used. Okay, below this again one more braid layer will be there. If you just cut the gas hose pipe at home, you will see all these things because it will be, since you are dealing with air which is hazardous in nature. Usually at home you are using butane. If that gets leaked, it causes suffocation and it catches fire. That is why precaution will be taken for making the pipe with successive number of layers. More number of layer will be there so that it shouldn't get leaked. Okay, and last inner layer where your compatibility of fluid flow comes into picture because liquid is in contact with this part. So above this there is a second layer of braid. Above this there is one more layer of braid wires. Outermost will be made up of synthetic wire. So 4 layer comes in a flexible hose pipe which will help us in achieving a fluid flow precisely, smoothly and accurately. This is about hydraulic fittings and conductors. Hope this session has reached you efficiently. Successive sessions will be continued by my colleagues. Thank you.